to 2 minutes, although it's important to get to the 2 minutes by the time you get to the test. I think in practice it serves students a little bit better to take a little bit more time when they're first practicing. So let's settle in and let's get started. So let's see, first question for us is going to be this guy, and we're going to set our clocks for 3 minutes starting now, and let's take it away. Okay, guys, this problem here is probably one of the most time-worn of all GMAT 3-time distance problems. So we're dealing with average speed, and average speed is something that you have to understand well. Now, here's the thing to remember. If any of you did something like this, you said, 4 plus 10 over 2 is 14 over 2, which is 7, and chose answer choice E, you made a classic mistake. And the classic mistake is that you can't, hold on, let me mute. Hold on a sec, guys. Okay, that's better. You can't take a simple average with ratios. And if you think about it, what miles per hour are ratios, right? Because, oh, hold on, let's see who's doing that. Okay, yeah, guys, keep your mics muted. Let me mute everybody. Okay, cool. So if you think about like 4 miles per hour, it's 4 miles over 1 hour, and like 10 miles per hour is 10 miles over 1 hour. So these guys are ratios, so rates are ratios, and you can never take a simple average and expect to get the correct average when you're dealing with ratios. So instead, what we have to do is we have to remember something really important. We have to remember that average speed, which is what we're being asked for here, average speed is always equal to total distance divided by total time traveled. And as long as we follow this formula, we can nail these questions every time. Now, it's helpful to elaborate on this formula a little bit further. And what I mean by that is the total distance in a scenario like this problem would be d1 plus d2 divided by t1 plus t2, right? Because we have two distances and we have two times that are associated with those distances. Here's the other interesting thing. A lot of students at this point say, well, wait a minute, there are no distances given in the problem stem. And that's fine. What's interesting is we don't need them. It doesn't matter. It doesn't make a bit of difference what they are. So what I like to do is just say that the distance from home to school is x, and then obviously the distance back is x. So if you think about it, the total distance she travels in this problem is 2x. Now, follow closely here. So the time we can kind of elaborate on further as well. Because if you think about it, time 1 is nothing more than the first distance over the rate at which she traveled. And time 2 is nothing more than the second distance over the rate at which she traveled, which is just 10. Okay? And the reason for that is, remember, time is equal to the distance over the rate. So that's all I did here and here. I said, time 1 is x over 4, and time 2 is x over 10. Let's mute these people so we don't hear that. Okay, good. Okay, so then in the numerator, what we have is 2x, and then down below, we're going to have to add these two fractions together. So we're going to have to make sure, obviously, we get a common denominator. And if we do that, we're going to get, 7x over 20. Now, to divide by a fraction, all we have to do is flip and multiply. So this is 2x over 1 times 20 over 7 over x. And I want you guys all to see this, so I'm going to just pause for a minute, let you catch up, because this step is important. What I want you to see is that the x's invariably cancel out of the equation. Right? That's the reason why the x's really didn't matter. Okay, and what we have is 2 times 20 over 7, or 40 over 7, which as a mixed number would be 5 and 5/7. So in a second, we're gonna review this problem once everyone has a chance to catch up and take a few notes here. Okay, so in summary, you can't take a simple average when you're dealing with rates. So what you can't do is say, okay, she travels at 4, she travels at 7, the average of these two, travels at 4, she travels at 10, the average of these two guys is 7. It doesn't work that way. Because if you think about it, she's traveling longer at the slower time, which sort of skews the average away from what it would be if you were just taking a simple average. So anytime you see average speed, and it's a question like this, what you want to think about is the average speed formula, which just says total distance over total time. And of course, here what we did is we got more and more elaborative with what this formula means. Okay, and if you notice, 5 and 5/7 is the correct answer, which here is answer choice C. And for those of you guys who are just tuning in, it's important to see that 7 is the trap. And in fact, a kind of a good guesstimation here is that the average speed will always be less than what you would get with taking a simple average. Okay, so if you had a couple of seconds left and you had to guess and the answer choices were structured properly, you could use that to your advantage. Okay, all right. Let's get another problem loaded up here. Okay, so we're going to give this one a whirl. And again, tonight the problems will be similar, but a little bit different. Obviously still under the genre of rate, time, distance. So let's shoot for about 3 minutes on this guy, and let's set our clocks now. Yeah, guys, if you get an answer, you can type it in the chat. Just make sure you address it to everybody so we can see what you're getting. And if you don't get an answer in the 3 minutes, it's not a big deal. You're here to learn. All right, about a minute 45 in. Okay, guys, that was about 3 minutes. And as I told you in past webinars, it's important just to kind of maybe set a double timer. So you do want to know what 2 minutes feels like. So have your iPhone or whatever you're using alert you at 2 minutes, and then also another one at 3. So in this problem, we have Olivia. She can run X miles in Y minutes. And if she runs at a constant rate, which of the following represents the number of miles she can run in Z hours? Now, on all GMAT questions, you have to always be cognizant to the units. So many, if not all, quantities in our universe come with units attached to them, right? 20 feet, 16 minutes, 100 yards, 14 cups, 20 ounces, whatever you're using, okay? You can't mathematically work with dissimilar units and expect to get a logical result. For example, if you multiplied 20 miles by, I don't know, 26 feet, the result is totally illogical. Now, this is an extreme example, but you can see that miles times feet don't do anything for you. Okay, the result would be some weird unit that wouldn't make any sense. So on GMAT questions, especially rate, time, distance ones, you got to make sure that all of your units match. And if you look at this question in the STEM, you can see right away we have a rate that's expressed in minutes. However, the question is asking us for how long she can run in hours. Now, minutes and hours can be easily and accurately interconverted, but you have to make that interconversion. You can't work in one unit in minutes and then the other minute in hours, or we're going to get a bogus result. So if you think about it, what's her rate? Well, it's kind of given in a pseudo-sneaky fashion, right? Because we know rate is distance over time, and the problem tells us she runs X miles in Y minutes. So really what they're giving us there is they're giving us her rate, right? So her rate is X miles divided by Y minutes. That's her rate in miles per minute, right? And we may even want to tighten this up a bit and say, well, that's the same thing as X over Y miles per minute, whatever makes sense to you. Okay, now if we're ever going to get to Z hours, we have to convert this rate from units of minutes to units of hours. And the way we do that is by making a unit conversion. So let me show you how to do that now. So what we do to make a unit conversion is we start with the unit we have in question, which is X over Y miles per minute, and we multiply by the conversion factor. Now, the conversion factor is the known fact that it's true that 60 minutes is the same thing as 1 hour. Now, for those of you who are rusty at this or are new to this, I want you to see that we had to make these fractions so that the unit we did not want anymore canceled off. So I want to go from minutes to hours, so I made sure to stack the fractions such that the unit of minutes would cancel itself out of the conversion. Right? So if you think about it now, what are we left with? Well, in the numerator, we have 60 times X, and the unit left in the numerator is miles. And if you think about it down below, we have Y, and the unit left is hours. So this is helpful because if you think about it, guys, we went from a rate in miles per minute to a rate in miles per hour. And that's exactly what we need because remember, the question is asking for how long can she run in Z hours. So guys, now finally at this point, we can say to ourselves, well, distance is equal to rate times time. Okay, so how far she can run is her rate, which is 60 X over Y miles per hour. Multiply that by Z hours, and you may want to put it over 1, just so you realize that it is a fraction over 1. Notice, guys, if we do the fraction properly, the hours cancel out of the equation, and we're left with distance, which is exactly what we were hoping to solve for, right? So her distance would very simply be 60 times X times Z over Y, and of course the unit left is miles. And let's see, what is that? That's answer choice B. Okay, so let me summarize. Whenever you're doing a GMAT question, particularly like a rate times distance or a work or something like that, or a mixture, it's really important that you're dealing in like units. So in this problem, we had minutes and hours. So we converted her rate in miles per minute to her rate in miles per hour. Now, a good question the student always asks is, could we have done the reverse? Could we have converted the Z hours into Z minutes? And the answer is yes, definitely. We absolutely could have. So whatever you choose to convert is totally up to you. The best thing to do is to usually pick the one that's going to be the faster conversion. Now, what does it mean to have the faster conversion? Well, usually objectively, there's one structure that's easier to convert than the other. That's usually the one you want to go for. However, if your eye sees something that just makes sense, you can convert away as you need. So I think this problem is an important takeaway for students because all the time, what I see is people do these questions and they get it wrong, not because they don't know how to do rate time distance, but because they forget to convert the units. So be really, really careful of that. Okay, let's do another. The next one is also a really classic one, and I am copying from a Word doc, so excuse the red underlining here. So let's set our clocks for 3 minutes, and let's take it away starting now. Okay, guys, that was about 3 minutes. So what we have here is a really classic GMAT rate time distance problem. So you have Dorstein, he's in Easton. You have Tom, who is in Weston. These towns are 240 miles apart. So sometimes it's helpful to make a brief sketch to model these guys. So what we have here is we have, I guess depending where east or west is to you, let's say this is Weston and this is Easton. and these two towns are 240 miles apart. And Thorstein and Tom leave at the same time and drive towards each other. So what we would say is this is a converging rate question. It's a converging rate question because we have two objects here, Thorstein and Tom, and they're driving towards each other. Okay? It says if Thorstein drives at a constant rate of 60 and Tom drives at a constant rate of 40, how long will it take before they meet on the road? Now, as these problems start to get a little bit more complex, I really like to make a matrix, and this is something that we at Target Test Prep really emphasize with a lot of different types of word problems because it makes your job so much easier. So if you've never seen this, you've never done this, or you're not studying with us, I want you to see how easy it is to break this down. So we're going to have a line like this, filling the box up and down, and then we'll make a column for rate, we'll make a column for time, and we'll make a column for distance. Now we have two characters in the story, so what we do is we put the two characters in the rows. So there's Thorstein's row, and then there's Tom's row. And then what we do across the top is we say, okay, we know the formula that's modeling this story here, this problem, is rate multiplied by time is equal to distance. Okay, and rate, time, and distance now define the columns respectively. Okay. So now it's really a matter of just plugging in intelligently. So let's think about it. It says they leave at the same time and drive towards each other. So in a converging rate question, what that means is their times are going to be the same, right? However long it takes them to meet is going to be the same for Thorstein and for Tom. Right? It doesn't matter what the time is. However long these guys take to converge, it's going to be the same for either of them, for each of them. So what we can do is we can let both of their times be t. Okay, let both of their times be t. Now, we are given Thorstein's rate, right? Thorstein's rate is, let's see, so Thorstein's rate is 60 miles per hour. We're given Tom's rate. Tom's rate is 40 miles per hour. And at this point, a lot of the hard work is already done, because if you think about it, we know that rate times time is equal to distance. So therefore, Thorstein's distance traveled is equal to 60 times t, right? Just algebraically speaking. And Tom's distance traveled is 40 times t, just algebraically speaking. So usually the best standard operating procedure is once you have two of the boxes in any row filled in, you can just, in this case, perform the multiplication to get the third row, third box. Okay, so what I mean by that is once we had 60 and once we had t, we multiplied these guys to get 60t, and once we had 40 and once we had t, we multiplied those characters to get 40 times t. Okay, so now here's the next important step. I want you to see that the distance that Thorstein travels plus the distance that Tom travels is going to have to sum to the distance total. And I want you to think about that for a minute, because that's a really crucial part to the question. So if one leaves from the west and one leaves from the east, it doesn't matter where they meet up, right? It doesn't matter whether they each cover half the distance. Well, half and a half is the whole. It doesn't matter whether one covers 3/4 and one covers 1/4. Well, 3/4 and 1/4 is a whole. It doesn't matter if one covers 1/7 and one covers 6/7. Well, the sum is still 1. Right, so any way you slice or dice it, it's going to have to be true that the sum of their distances must be the total distance that they converged over. Okay, that's a really important point. Make sure you take a note of that. Okay, because with that formula, what we can do is now say the following. Well, we know Thorstein's distance is 60 times t. We know that Tom's distance is 40 times t. And we know the total distance these guys covered is 240. Let's see, someone has their camera open. I can't tell who it is because it covered up the name. So guys, check and make sure your cameras are closed. I don't care if it's open, but just know that somebody has their camera open. Let me change back to normal screen. Okay. All right, cool. So 60t plus 40t is 240. So we see that we have 60 and 100 is 100t is equal to 240, right? So what we're going to do now is say t is equal to 240 divided by 100, right? You can reduce this down any way that seems to make sense, but it seems like the easiest thing to do is say that this is 12 fifths of an hour. Okay, so I'm going to stop right there and let everybody catch up. I picked some hard problems for you tonight. So make sure you catch up to that point. Okay, so some of you are saying, well, how did you know it was in hours, right? Where did the hours come from? Because I didn't carry the units with each step of the way because it's kind of burdensome. But if you remember, if you go back to the problem, right, we have speeds in 60 miles per hour and 40 miles per hour. So that means that time, we didn't adjust those rates. So this time is in hours. And if you look at all of the answer choices, all of these suckers are in minutes. So another example of having to be really careful with the units. But we're okay, because all we're going to do now is we're going to convert 12 fifths of an hour into minutes. And this won't be a problem, right? We'll say 12 fifths of an hour. And we know that there are 60 minutes in every 1 hour. Now notice I structured this such that the hours would cancel with the hours, because if you think about it, what we want is we want to be left with a time in minutes. Okay, so we'll do this strategically. 5 goes into 5 once, 5 goes into 60 12 times. So this is 144 minutes. So in other words, 12 fifths of an hour is the same thing as 144 minutes. And if we look up at the answer choices, that's answer choice D. Now, let me clarify one other thing that students often ask. So remember, it says how many minutes will it take before Thorstein and Tom meet? Well, T was the time for both of these guys. So T is T, right? Doesn't matter. T has the same meaning, which is what we solved for down below. And the time for one is the time for the other. Okay? All right. Get down whatever notes you want to get down on that guy as I get another question. Okay, this guy's pretty difficult too. So let's set our clocks for 3 minutes. And let's see what happens between Newark and Boston starting now. Okay, guys, that was about 3 minutes. So let's see what's going on here. So the distance between Newark and Boston is 245 miles by train. So train A leaves Newark at 12. It's traveling to Boston, 50 miles per hour. Train B starts off from Boston at 12:30 and heads towards Newark at a constant speed of 60. So the trains are traveling on parallel tracks. At what time do they pass each other? Okay, so if you think about what's going on here, we have two towns, doesn't really matter what they are. We have Newark and we have Boston, and the distance by this train is 245 miles. Now, this problem is more difficult than the last one because we have to be aware of a couple things. So let's actually start by just drawing our matrix so we can get some essential data filled in here. So we have our rows. I don't mean to make arrows, but you see the point. Okay, change our color. Okay, so remember the rows are the characters. In this story, the characters have to be two trains, train A and train B. And of course, because it's a rate times distance problem, we'll let the columns be rate multiplied by time, we know is equal to distance. And guys, I want you to notice one thing. I'm taking a really mechanical approach with these. You know, some people advocate for using just logic and just trying to like eyeball these. You know, I've never seen it work. I can't do it. I've very rarely seen students been able to do it. And that's one reason why I think rate time distance struggles people. What I'm doing is giving you a really mechanical approach. Make it take a couple seconds longer, but remember the shortest way is the way you know. And if you do a problem elegantly in 8 seconds and get it wrong, what was the point of doing it? So these are definitely problems that I believe require some really careful analysis and setup. And this is what we're giving here, a really mechanical approach. Right, so what we can do is start filling in our data, right? So train A, it says it travels at a constant speed of 50 miles per hour. Train B travels at a constant speed of 60 miles per hour. Now, here's where I want everybody to pay close attention, okay, if you weren't before. So notice, train A leaves at 12, but train B leaves at 12:30. So if you recall, in the last problem, what we did is we let both of the times be t, right, because they left at the same time and they converged, you know, at some time later. We can't do that here because they didn't leave at the same time. So let me show you what students' natural inclination is, which is wrong, right? They're going to say, like, I don't know, so let's say, so who leaves? So train A leaves first. So they would say, okay, train B travels for t hours, and then train A, because it left earlier, it travels for longer. So they say, okay, that's t plus 30. Well, no, we can't do that because remember, although we're not writing the units each time because it's kind of laborious to do that, remember the rate that we were given, for the rates that we were given for these trains are in miles per hour. So you can't drop minutes into the equation, right? 30 minutes, yes, is a half of an hour, but you can't put 30 there, okay? So instead, what we need to do is make sure that the time column is properly expressed with hours. Okay, so we'll let train B's time be t, right? He leaves at 12:30, and then train A's time is t plus 1/2, because 30 minutes is the same thing as 1/2 of an hour. Okay, we need to reflect the fact that train A travels for longer, but we have to make sure we do it with the proper units. Okay, so it's going to be t and t plus 1/2. And that, I think, is the most difficult part of the problem. So now we have the rate column filled in, we have the time column filled in. So algebraically, the distance of train A is 50 multiplied by t plus 1/2, and the distance traveled by train B is simply 60t. Okay? I'll give you a second to catch up to that. Okay. Now, because the two trains are converging, right? One leaves from Newark, one leaves from Boston, and we want to know at what time will they pass each other, we have another converging rate question. And remember, in converging rate questions, it must be true that the distance of object A, whatever it is, in this case a train, plus the distance of object B, whatever it is, in this case a train, is going to have to sum to the total distance between these two. Okay. Well, we already said that the distance train A travels would be, let's see, that would be 50 times t plus 25 after we distribute the 50 through, plus 60 times t, right, that's the distance that train B travels. And because the total distance between these two towns is 245 miles, we set the equation equal to 245. Okay, so let's subtract the 25 to the right-hand side. This gives us 220. Let's combine like terms on the left. This gives us 110t is equal to 220, or t is equal to 2 hours. Going to make sure the units are in hours. Now, in classic GMAT fashion, we always have to make sure that we're properly answering the question. Always have to make sure. So it says, if the trains are traveling on parallel tracks, at what time do they pass each other? Well, we got to be a little bit careful here because we said t is 2 hours, but remember, look up into the table. Yes, t is 2 hours, but I want you to notice that t is the traveling time for train B. So what we have to do is look up there and see, what time does train B start? Well, train B starts at 12:30. Okay, so 2 hours later would be 2:30. Now, could you have done t plus a half? Yeah, of course you could. It just would have been an extra step. But the point I'm making here is that, on the GMAT, it's designed so that you can do a bunch of work, and in some questions you could find 4 answers that are wrong yet familiar because they're either part of the question or they just seem like they're the right answer, or they're a calculation you did somewhere in the mix or something like that. So you never want to do all that work at the end only to answer the wrong question. And I honestly think that's why sometimes students take the test and they're like, wow, I was getting a 650, I just got a 600, what happened? I think that sometimes if we're rushed or not being careful what we're doing, we can have a tendency to make some careless mistakes. And as you know, the test is well designed to induce you to make those mistakes if you're not careful, right? It's not like the typical test that a teacher in college would make where they really don't spend too much time on the wrong answers, right? They just eyeball them and they make sure the right answer is there. Well, no, on the GMAT, the other 4 wrong answers are based on thousands or tens of thousands of what other students have done. So kind of scarily, they know what large groups of people would do given these problems, maybe even better than the people themselves. So just be careful. Okay, so the next question, before I give you the next question, let me give this to you. I'm going to put this in chat. So if you come regularly, or you would like to come regularly, we really do try and tailor these webinars to feedbacks from the students. So like a couple of you mentioned the 2 minutes was not enough based on the difficulty of the problem. So if that was one of you, you can see now we're at 3 minutes just to give you a little bit more time. So if you want to fill out that feedback sheet, we'll try and take any suggestions you have, and if there's any types of questions you want to see us do, so it really will benefit you. So please do take the time to fill that out and let us help you a little bit better. All right, so let's see, what are we going to do next? So I actually fed the dogs prior to the webinar tonight, so they're not hounding me. Those of you who come regularly know this is about the time where they start to come into the office and tell me it's time to eat. Okay, let's do this guy. So this is another difficult one. Let's take this away now, set our clocks for 3 minutes. All right, guys. So this is a problem that's very difficult, no doubt, but we can make it as simple as possible. So we have Thomas. He's riding his bike at a constant speed of, doesn't give us a constant speed, but we know the store is 60 miles away. It says if he had ridden his bike 2 miles per hour faster than he did, he would have saved an hour. And we want to know how fast did he ride. So I kind of like to refer to these as if-then questions because they give us a real scenario and then they give us sort of a hypothetical. But the good news is we can still use the matrix approach here. And on test day, obviously, you wouldn't have the ability to make boxes. So let's not make the boxes anymore. We'll just say we have the actual speed, and we have the faster speed, and we know that we have rate multiplied by time is always going to give us a product of distance. Okay, so the algebra for this comes into the rate column. Because we don't know the actual speed, nor do we know the faster speed, but with the power and beauty of algebra, we don't need to, right? We can say that the actual speed is r, and then the faster speed, or some people like to call this the hypothetical speed, the faster speed must be r plus 2, because the faster speed is very simply 2 miles per hour faster than the actual speed. Now, notice that the store is 60 miles away in both scenarios, right? It doesn't matter how fast this guy rides his bike, the distance to the store is not going to change. So this is the first time you guys have seen this tonight, but it's in line with what I said. Once you have 2 columns filled in, usually all you have to do is perform the right calculation to get the third. So if you see here, we have rate and we have distance filled in. Well, time is simply equal to distance divided by rate. So watch this. This is important to see. The time actual is simply distance over rate for actual, and the time for faster is simply distance over rate for faster. Okay? Now, it's definitely challenging, so pay close attention. So check it out. What we know is if he had ridden faster, he would have saved an hour. So I'm going to write the equation first, then we're going to talk about it. So what I'm going to say to keep me from making a simple mistake is the faster time plus 1 hour is going to equal the slower time. Because the weird thing about this is the slower time is actually greater than the faster time, right? So to get the equation to balance off, we have to put an hour on the faster time to have it equal the slower time. And once we do that, it's pretty easy, right? Because we said the faster time was 60 over r plus 2 plus 1 is equal to the slower time, which is equal to 60 over r. Okay, so that's our equation. Now, it's really just an exercise in algebra. And our first step here is we want to get rid of the fractions. And the way to do it is to multiply by the least common denominator. The least common denominator is just the first number that all of the denominators will divide into, right? So take a minute and think about it. What's the least common denominator here? Some students think r, but it's not r. Some students think it's r plus 2, but it's not r plus 2. What it is it's r multiplied by r plus 2. All right, that's the first number, if you will, that r plus 2 and r will both divide into. Okay, so let's multiply. And remember, we have to multiply this by every term in the equation. And when we do that, we're left with 60r plus r plus 2 is equal to 60 times r plus 2. This becomes 60r plus r squared plus 2r is equal to 60r plus 120. Many of you just saw the quadratic equation reveal itself. That was hidden before. Okay, we can these 60r's, right? Get rid of those guys. We don't need them anymore. So we have r squared plus 2r, and I'll subtract the 120 from the right to the left, and we know that's equal to 0 now. At this point, we're just going to get the factors of this quadratic. Okay, so we need an r, and we need an r, and we need a plus and a minus. And we need these guys to multiply to minus 120, but add to 2r. And let's see what numbers would work. Looks like we need a 12 and a 10. So the two solutions would be r is minus 12 and r is 10. Now, a lot of new students say, wait a minute, what did we do wrong? You know, how can we have negative 12 and 10? And the answer is that the equation is not intelligent. The equation is a blunt instrument. The user of the equation has to interpret its result. So it doesn't know that minus 12 doesn't work because rates, at least on the GMAT, are not negative. In physics, we have negative rates, but we're not going to experience that in the GMAT. So, for example, time wouldn't be negative, distance wouldn't be negative, rate wouldn't be negative. So what we have to say is, well, that we just simply take the positive root, and the r value is equal to 10. And that's exactly what we're asked for, because remember, r is the actual rate, and the question is asking us for what's the value of the actual rate. Okay, guys, so again, for your sanity, these were some great problems most students of most goals should work on and get good at. But if this is the first time seeing this, or if I took a different approach, it's obviously going to be new to you, especially if you're used to some of the other watered-down approaches that are out there. So keep practicing with this stuff. It's hard, yes, but the more you work at it, the easier it's going to become. I appreciate you all coming here tonight. I know some of you are in the deep snow, so thanks for making it. If you have any questions, send me an email. Whatever you'd like to do, I'd be more than happy to help you. Otherwise, we'll look forward to seeing all you guys here, same time, same place, next Tuesday. Okay, and guys, try not to forget to fill out that form if you have any feedback, and we'll look forward to seeing you soon. Take care, everybody. Good night.